Hi, my name is Alex Lopez, and this is my lab report for Physics 2212 Lab 2. The purpose of this lab is to estimate the change in charge of two separate strips of Scotch tape by calculating the number of electrons that transferred between the two strips when they are brought close together. And so some of the physics fundamentals of this lab. So the tape was meant to model point charges, and for this it was assumed that the tape is used to have an equal and uniformly distributed charge so that we may apply Coulomb's law. And in order to calculate the charges of each piece of tape, we use Newton's second law and Coulomb's law. And using the estimated dimensions of an atom, it is possible to calculate the number of excess and deficient electrons per atom for each piece of tape. To give a brief preview of the results, once the charged strips of tape were brought together, they repelled each other, and afterwards the strips of tape were observed to be positively charged. And in the end, their charges were calculated to be 1.58 times 10 to the negative 8 coulombs, and each strip was found to have lost 9.87 times 10 to the 10 electrons. So to give some details on the experiment itself, in order to conduct it, I first stuck tape A on the table and ripped it off, which caused it to either gain or lose electrons. And then I tested the charge by bringing it close to differently charged objects, such as my hand and a pen. And then I placed tape A underneath tape B, which was assumed to have a similar charge, and then measured the distance between the two pieces once tape B started to hover with tape A under. So I observed that the tape was attracted to my hand, it was repelled by the other strip of tape, and it was attracted to a negatively charged pen. So from that, I was able to conclude that the strip was positively charged, meaning that it lost electrons in the process. So as far as the actual numbers, I measured the length of the piece of tape to be 0.254 meters, and assuming that tape has a approximately 1 gram per meter, its mass was then 0.000254 kilograms, and I measured its width to be 0.021 meters. And the distance between the strips, once they were brought close together, was 0.03 meters. And so then we were able to find the force of gravity, and using that, we could find the actual charge of the tape, which was 1.58 times 10 to the negative 8th coulombs. This is the glow script model of the calculations I just described. You can see on the right, the orange arrow is the electric force, and the green arrow is the force of gravity. And as you can see, both of those arrows are equal and opposite, so the top piece of tape was in equilibrium. So for some discrepancies and sources of error, the pieces of tape were treated as point charges for simplicity of calculations when they are obviously not actually point charges, and their actual charges were not likely to not be exactly the same, even though they were treated as such for the calculations. And likely touching the tape with other objects might have caused its charge to change, and measurements, like physical measurements that were made during the experiment, may not have been exact. So if electrons had positive charges and protons had negative charges, that actually would not have changed the observations we made during the experiment, because opposites would still repel each other and like charges would still attract. So regardless of whether it's positive or negative, it would have the same physical effect. And it's important to handle the charged tapes as little as possible, because anytime they come in contact with any other object, that may cause any sort of change in charge.